Good day, children. Today we are going to start with a new topic, that is force and laws of motion. As in the last class, we have learned the topic motion. We have learned the basic components of motion, or when an object has to be defined in a state of rest or in a state of motion. So today, let us see how motion is explained in terms of force. Consider one duster, say any object, and a wooden plank. If I say the duster is kept on the wooden plank, you would say the object is in the state of rest. Another name for this, we say that it is in the state of fixed position, or it is stationary. Do you say that there is no force acting on this object? Let us see if this object is moved from position A to position B. So you could see the object has been displayed from one position to the other. So in the same way, when I say the object is taken and when I apply a force in a different direction, the object is being displaced. In this way, I say that the object is in motion. So when a force is applied to any object, the object will be in the state of motion. But if the motion, or if I say an object has to be in the state of rest, can force be applied? Think about this question. Consider a chalk which is cylindrical and the wooden plank. If I roll on the chalk and it is being in motion, and after some time you will see that it is in the state of rest. It has stopped. What may be the reason that the object has stopped for a moment, when initially the force was applied and later it has stopped? Yes. So we say that the object can be in the state of rest and in the state of motion where the force is also applied. Just imagine this chalk when it is thrown. So I have cast it in order to resist the flow of motion to the next direction. So there are effects of force to any object when force is applied. So what are these effects of force? Let us see in more detail. Here is a short game to check on the effects of forces. So let us see what are the effects of force. So let's start. Here we need to drag each of the pictures shown alongside with the effects that you look. You can see a person who is trying to catch the ball, that is in a game of cricket. So in which would it come? Force can move a stationary object, or can it stop a moving object? Force can change the direction of motion, or force can change shape and size of the object. You can see it will come that the person who is in the fielder, he will try to stop the moving object. Let us try one more sort of, where here we are seeing that the dove is being net. So you can see the shape of the object will be definitely changed when the force is applied. So it will come to the force that will change the shape or size of an object. Here a person is carrying the trolley in one particular direction. So the force can definitely move the object because it was in the stationary and it has been fixed up. A boy playing football, he has changed the direction to with his kick towards the ball. So we will say that force can change the direction. Even a person who is playing a baseball, so the same, that is, the direction can be changed. On the other hand, we can see a pot is prepared by a potter. So you could see that the lamp or the direction, or you say the shape is being changed, the size can be changed with the application of force. On the other hand, we see that a boy who's playing with the tire. So either the force can move the stationary object or can it stop a moving object. So you can see it is being, the force can move, whereas the goalkeeper, he always tries to stop the moving object. So in this way, we have seen the arrangement, and look at the answers alongside, where we have missed out that force can have four different times of force, can have different four effects when an object is being applied. So here, what do you say about force? Yes, force is defined as when an object is applied with an action of pull or push, where you may see the effects of force either in the change in dimension, that is shape or size, or you will see the change in the direction of the object in the motion, or you can state that the object has been provided from the rest to in the state of motion, or from the state of motion to the state of rest. In this way, we say that force is also defined as mass, that is the product of mass and acceleration. Force directly varies to rate of change of velocity. That is, force is equal to mass into acceleration. Can you identify what would be the unit for force? So let us derive the unit. So here we have force as kilogram as the unit of mass, acceleration as meter per second square. In short, the SI unit of force is Newton. That is, we call as in terms of symbol, that is capital N. So this states that the force is defined as product of mass and acceleration, and SI unit is Newton. Can you guess whether the force is a scalar quantity or a vector quantity? Yes, as you can see, force depends on acceleration. Acceleration being a vector quantity, force also is said to be as a vector quantity. Force can have negative value, force can have zero value, and also force can be positive. In which all scenario these values are affected, let us discuss more in detail. Consider this object, that is a duster placed on the wooden plank. Now you say that the object is in the state of rest. So as previously I asked that whether the object is having some force exerted on it or not. Let us get back to this answer after some time. Let us see if this object is placed at one end and I'm trying to apply the force. I have tried to the maximum and then I see that the force is applied and the object is moving in the opposite direction. When you say the object is moving in some direction, there is a force acting in the reverse direction as well as in the upward direction. That is, the force applied in the forward direction is the force applied by me on the duster, whereas the force applied by the surface on the duster's surface. Can you guess what is this force called? Yes, it is the force of friction. In the similar way, if I consider this platform and I try to give the force will not be so easy as compared to this plank. Because in this plank, the frictional force would be less, whereas on the other side, the friction force would be more. So, smoother the surface, the frictional force will be reduced. So, we say that for any object, when it moves from one position to another, there is always two forces exerted on the object. And both the forces are always opposite in direction, but the magnitude will always affect. When I say the object, say the duster itself, when it is applied in one direction, you can say that the force if towards the forward direction is more than the backward direction. But if the force applied was less, you could see that the object may go in the reverse direction. Because you say other force, that is force F, B and force FA, if I consider. Force A could be more than force B according to the direction it goes, and force B can be also greater than force A. But in the case where the object stays in the state of rest, yes, two forces exert. One is the top upward force, which we generally say as atmospheric pressure, which applies a force on the object. And the downward force is the gravitational pull, gravitational force. So both are balanced with each other. So here we come up with balanced forces and unbalanced forces. When an object is tend to move from one position to another, it will definitely have unbalanced forces acting on it. Whereas if the object is in the state of rest, as you saw this, we call this as balanced force. Whereas there is one more possibility where you may see both the sides when I apply equal and opposite forces. So like I'm trying to pull this duster and trying to pull this duster, and both the sides when together it is equal, we still say this is a balanced force. Can you think about an example where you see balanced forces exist? Yes, we have a game called Tug of War, where the opposite team always tries to pull towards itself. So the force being towards is more, whereas the forward force would be less. But there will be a situation where you will see that both the forces, that is both the team are applying equal forces, but they are acting in opposite direction. In that state, you will observe that the bow which is put at the center of the rope remains in the state of rest, or it is stationary. In this case, it is the balanced forces applied. Let us see an example more on this. Here, this is the definition of force. That is, force is called as a push or pull action exerted on an object. The SI unit of force is Newton. Force can be represented as by magnitude as well as by direction. So it is called as a vector quantity. Net force, that is the total force, we say that it is the result of combination of all the forces exerted on that object. Let us see here some examples where you could see 20 Newton on other side and 10 Newton on the right side is being applied. So the net force, that is the total force, they have said as 20 minus 10, that is 10 Newton. How this has come up? And could you identify whether the object will be moving towards the left side or towards the right? Yes, it will be towards right with a total force of 10 Newton, wherein you say it is being subtracted because 10 Newton which is applied from the right side, it is in the opposite direction towards the force which is applied with 20 Newton. So the total, when we have to find the negative force, that is 10 Newton, we need to consider and find the value as 10 Newton as the total force applied. In the similar way, when we consider the same block, when the force is applied in the same direction, it will be always added. That is 10 Newton plus 10 Newton is 20 Newton. Here, let us see what are the examples of balanced forces. A stationary object will not move while the forces acting on it are balanced. Balanced forces do not cause change in motion. They are equal in size and opposite in direction. Net force on the object, the total force, like 50 Newton on other side, and this side also we have a 50 Newton. So definitely it will have the total force 50 minus 50 as 0 Newton. We see that no force is applied. This is caused because both the forces are cancelled with each other, with their direction and magnitude. Both is affected. Here, the truck, if you see force pushing the truck, on the other side also is pushing the truck. Both the situation when the force is applied, you could see that the truck still stays still. That is, it is in the fixed position. So such examples we shall consider in balanced forces. Unbalanced forces. You could see here an example where the person F1 is applied with a force 50 Newton. On the other side, right hand side, we could see 70 Newton the force is applied. So the net force would be definitely 70 minus 50, that is 20 Newton. But the block will move towards left or right. Yes, it will move towards left since 70 Newton is more than 50 Newton. So when the net force of an object is not zero, the forces on the object are unbalanced. An unbalanced force always causes a change in motion. So in this way we have seen what are balanced and unbalanced forces.
Today we are learning about balanced and unbalanced forces. Now, balanced forces are forces that are equal in size but opposite in direction. And you can identify balanced forces because they do not cause things to move. Let's look at an example. If we had a box on the floor and you tried to push it from one side, but your friend pushed it from the other side, the box would not move. Therefore, this would be a balanced force. Both you and your friend would be pushing equally hard, so your forces would have an equal size, but you would be pushing one way and your friend would be pushing the opposite way. You're pushing in opposite directions. These two forces cancel out, the box would not move, and we can call them balanced forces. In contrast, unbalanced forces are simply any forces that are not balanced. So for example, if you pushed a box from one side and your friend came to help you, you're now pushing in the same direction. When you push on the box, you will find that it definitely will move. So this is an example of an unbalanced force. Your forces are not canceling out. Here's another example. If you went to push this box, but your friend came to push on the other side, you're pushing from opposite directions, but we can see your friend is much larger. They will be able to put down a much bigger force than you will. And because your forces are different sized, these are unbalanced forces. If you both push, the box will move because your friend is pushing harder. Let's look at some of these together. Let's look at this tug of war contest, and we'll pretend that every person is the exact same strength. Based on this, how could you describe the forces of the blue team compared to the red team? You could say the forces are equal in size because the blue team has 1, 2, 3 people or 3 forces pulling, and the red team also has 1, 2, 3 people or 3 forces pulling. Next, how could you describe the direction of each team's force? You could say the teams are pulling in opposite directions. We see the blue team is pulling to the left and the red team is pulling to the right. So are these forces balanced? Yes, we can say these are balanced forces because they are equally strong and they're happening in opposite directions. Let's look at another tug of war contest. Now we can see here that the blue team is pulling to the left and the red team is pulling to the right. They're pulling in opposite directions. But how could you describe the size of each team's force? Well, you can see the blue team is a larger person. They're going to pull with more force than the red team, who's a smaller person. So these forces have different sizes. Therefore, how could you describe these forces? These are unbalanced forces because they are not equal in size. If you were to watch this tug of war contest, you would see that the blue team would end up winning. Here's one more tug of war contest. Now this one looks a little weird. Even though the teams are pulling with equal force, their forces are equal in size, the blue team has 3 forces, the red team has 3 forces, it doesn't look like a normal tug of war contest. How would you describe the direction that these two teams are pulling in? You would say that both teams are pulling in the same direction. They're all pulling to the left. So do these represent balanced or unbalanced forces? These are unbalanced forces. There will be movement, and if you watch the tug of war contest, they'll easily pull the rope because there's no one pulling in the opposite direction. Now it's time for you to practice on your own. Do these represent balanced or unbalanced forces? Why? Well, these forces are equal in size. Both people will be pushing equally hard, and they're pushing in opposite directions. One person's pushing from the left, the other is pushing from the right. So because these forces are equal in size and opposite in direction, they will cancel or balance each other out. These are balanced forces. The box is not going to move. Here's another example. Do these represent balanced or unbalanced forces? Why? Well, these people are pulling in opposite directions. The blue team is pulling to the left, and the red team is pulling to the right. But these forces are different sizes. The blue team is much larger than the red team. So these are unbalanced forces. If you were to watch this tug of war contest, you would see the blue team wins because they can pull with a stronger force. Now here's one more. Are these balanced or unbalanced forces? Why? Well, these forces are in opposite directions. We have 2 people pushing from the right and 1 person pushing from the left. However, these forces are different sizes. Because you have 2 people pushing on one side and only 1 person pushing from the other, these are unbalanced or not equal forces. If you let everyone push, the box would move to the left because 2 people are stronger than the 1 person. So from today, remember, balanced forces are equal in size but opposite in direction. And in balanced forces, they do not cause any motion.
So, in this way, we have learned what are balanced and unbalanced forces. Now, since we have learned what are forces and what are the different types of forces that exist, now let us learn what are the different laws of motion. Laws of motion are said, like in terms of when you see the object in the state of rest or in the state of motion. So accordingly, we have framed some hypothesis on the state of motion or in the state of rest. Consider a chalk and a wooden plank. Now I'm going to roll this chalk on the wooden plank. You can see that it was set in motion and after some time it is in the state of rest. So what has caused this object to move? The force. What has caused the object to stop? Yes. Again, there is a force that is acting on the object that is called as the frictional surface over this chalk surface. So, the first law of motion states that Newton's first law of motion specifies a body continues to remain in the state of rest or uniform motion until and unless it is acted upon some external force to change that state. Just like you saw this example that when I had rolled the chalk over the wooden plank, you observed the chalk was in a motion, in a state of motion, because I had applied a force. That was an external force which I had applied. Whereas when the same rolling chalk had come to state of rest, it was due to friction. So frictional force is also an external force. So this is very simple to remember. Any object, if it has to be in the state of rest or in the state of uniform motion, it will remain till some external forces are applied on that object to change its state. For example, if I had to still roll on this chalk, I had to apply the external forces continuously. Or if I have to say the chalk still in the fixed position, I need to see that the frictional force is more. So here, let us see one Galileo's inclined plane experiment explaining the first law of motion.
Laws of motion by Galileo Galilei. According to Galileo, object moves with a constant speed when no forces act on them. This means if an object is moving on a frictionless path and no other force is acting upon it, then the object would be moving forever. That is, there is no unbalanced force working on the object. Let us explain with the help of an activity. Take two equal sized cardboards, place it against each other that they make equal inclination with the table. Assume that both surfaces are frictionless. Now take marble and release it from the inclined plane of the left side. You notice that the marble rolls down and moves up on the inclined plane on the right side. Now think about how far it moves along the second plane. Well, the slope of both the surfaces are same. Hence it moves the same height from which it is released. Now decrease the inclined plane on the right side and release the ball again. What do you see? It traveled large distance to reach the original height. We can keep on doing it, but what does happen when the slope of inclined plane eventually reduces to zero? That is, makes a horizontal. The marble will continue to travel forever until it reaches its original height. But it is impossible because all ideal conditions should be zero.
So this was the first law of motion explained by Galileo with an example of inclined plane. Just as we first experimented with a rolling chalk, we had a frictional force that was acting in an opposite direction to stop the object in the state of rest. But in the case of Galileo, he had considered two inclined planes where both were in the same slope. So we had studied that when the slopes are same, the object will be traveling at the same heights. Whereas if it is reduced, the height of the second inclined plane, which is at the lesser slope, will be traveling more height. Whereas if you see, I mean this more distance. But if it is kept in the zero slope, you could see that the object will still continue traveling. But still, as you know, the earth is still in an inclined plane, so it will stop for some extent. Since no surface we can see, it is frictionless. Now, let us discuss the activity 9.1, which is there on page number 117 of your textbook. So the activity states, make a pile of similar Karen coins on the table. As you play the Karen coins, and attempt a sharp horizontal hit at the bottom of the pile using another Karen coin or the striker. If the hit is strong coin or the striker, what would you see? Yes, once the lowest coin is removed, the inertia of the other coin makes them fall vertically on the table. So why does this happen? Any guess? Yes, it happens because of inertia. That is, inertia of the quantity will be affecting to the object. On the other hand, let us see the activity 9.2 that says if you set a 5 rupee coin on a stiff card covering an empty glass tumbler standing on a table, give the card a sharp horizontal flick with a finger. If we do it as fast, then card shoots away, allowing the coin to fall vertically into the glass tumbler due to its inertia. The inertia of the coin tries to maintain its state of rest even when the card flows off. So why does this cause? Yes, inertia is affected due to the mass of the object also. So we say inertia is the natural tendency of an object to resist a change in its state of motion or in its state of rest. An object will remain in the state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. An object will resist a change in a state of motion in a qualitative way. The tendency of undisturbed objects to stay at the state of rest or to keep moving with a particular direction or in the same velocity, it is called as inertia. This is why we say the first law of motion is also called as law of inertia because it depends upon the state of rest and in the state of motion. Now let us see, as we discussed in activity 9.2, the mass of the object affects the inertia of the body. So more the mass of the object, you say, more it will have the tendency to resist the change of state of motion. So since we perform the activity, you could see the 5 rupee coin is more heavier than 1 rupee coin. So it will resist itself to stay in the state of rest. Whereas as compared to 1 rupee coin, it will not. Also, if we say in which case is the lesser force, you could say that yes, the forces applied would be depending on the mass. Now, let us discuss an activity 9.3 in the similar way. The activity 9.3 says that hold a tumbler and try to whirl around or move around in a faster rate. Will you see that water is spilled in this case? So you would notice that water will not spill if you keep the velocity or the speed in the same position. But if suddenly you stop it, there may be chances that the water will spill. So we have three types of inertia, where the first type is called inertia of rest. Like for example, leaves fall down when branches shaken vigorously from the tree. When we shake a branch of a tree, the branch comes in the motion. But whereas the leaves of the fruit, leaves or you say fruits or flowers, they tend to remain in the state of rest till it is detached from that body. Inertia of rest is the tendency of an object or body to continue in the state of rest unless it is acted upon by an external force. Inertia of motion is another type wherein, for example, when a moving car suddenly stops or when the brake is applied, the person sitting in the car he will fall forward. The lower portion of the body is in contact with the car, so it will be in the state of rest, whereas the upper part is in the state of motion. So it is due to inertia of motion that the object is trying to resist itself to continue to change in state. If a body is in the state of motion, then it will continue to move at the same speed in the same direction unless an external force acts on it. So, inertia of direction is the third type, wherein when a car moves around a round curve, the person inside the sitting in the car, he will feel like thrown outwards in order to maintain his direction of the motion due to inertia. A body moving in a certain direction cannot change its direction without any external force applied on it. For example, when you travel in a bus, you may notice that when the bus is taking the right turn, you will be exerting yourself. You feel like you are being moving towards the left. So this is due to inertia of direction. Now, let us see a short video on first law of motion and summarize the topic.
Newton's first law of motion. In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever, or after some time would naturally stop moving? The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. To understand Newton's first law, you need to understand what unbalanced force is. If you have seen a game of tug of war, you would have seen two teams pulling a rope in opposite directions. If the rope doesn't move, the forces applied by the teams are balanced forces, as they are of equal magnitude in opposite direction. If one of the team applies greater force, it pulls the other team and the rope towards their side. In this case, the forces are unbalanced, as the two forces are of unequal magnitudes in the opposite directions. If one of the team lets go of the rope, the opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest, it tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion. Certain experiences that we have while traveling in a bus can be explained on the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is a tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of sharp brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body. When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in the state of motion due to the inertia of motion, causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is a tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia. Well, now this law should make sense. Do you understand why a ball on the ground after being kicked does not keep moving forever? The ball stops after some time due to the unbalanced external force applied by the ground in the opposite direction. Things to remember. Newton's first law of motion states that a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. Two unequal, oppositely exerted forces are called unbalanced forces. Newton's first law is also known as the law of inertia. The tendency of an object to continue its state of rest or of uniform motion in a straight line is called inertia. The three types of inertia are inertia of rest, inertia of motion, and inertia of direction.
So, in this way, today we have learned what is force and how unbalanced and balanced forces are differentiated, what are the different types of inertia, and also the first law of motion. We shall meet in the next class to learn more about forces of motion.